Miss Holcomb and Miss Hollister, that's your job.
Okay, I got it.
If you don't see that little red button in the top left-hand corner after 5 minutes of first class, then, you know. All right, so when the first one we're going to do is we're going to do an exponential. So right here, I'm going to take f of x, or y, so hit y equals, and we're going to do 2 to the x. And I'm going to delete that log. I'm not going to do that one yet. And graph. So you need to add that to your parent graphs if you don't have one. So I'm going to take my handy dandy. And the good thing about the exponentials is, and you can call this exponential graph. And this is when the variable is in the exponent. All right, it's always crossing at 1. Okay, no matter where it's going, just like this one, it always crosses at 1, at y is equal to 1. So let me move that over here a little bit. There we go. And it is increasing. How do you know it's increasing? Which way do we read?
Left to right.
So you put a little car on the left, and you tell me what that little car is doing. It's going uphill. Uphill is positive. And the reason I tell you that is you'd be surprised on how many people cannot tell what's increasing and decreasing on a graph. They just forget that they, you know, read left to right. I guess they think they're from the Middle East. Masalama. You know, they think they're from the Middle East. And they read from right to left. All of a sudden, after 12 years of schooling, you think you read from right to left with a graph. I don't know why students do that. For 12 years, they've been taught to read left to right, left to right, left to right. They look at a graph, they start over here. I want somebody to explain that to me, because I can't understand why you do that. If you've been taught 12 years, read left to right, left to right, left to right, why do you start over here? And to this day, nobody has been able to tell me why they start here after 12 years of schooling, starting over here. Okay, so there's your little car, and it's increasing. Now, with a logarithm, we'll go ahead and put that in there. And go down here, log of x. And remember, x is your basic model. So that's why it goes in the parent graphs. And I'm going to delete the first one. Well, no, I'm not. I'm going to show you something. Let me go ahead and make that a darker. Hit enter. Make that a dark line. You'd be surprised on how many people I make that in a dark line, and people go, I didn't know you could do that. Yep, you sure can. And X and close parentheses. And graph. And of course, there is your logarithmic. And you could say, let's say the log of 1 is 0. So I'm just going to go with this right there. There's your log. F of x is equal to log of x. So add that to your parent graph. And one of the reasons I'm showing you this is if you take a 45-degree angle and you draw a 45-degree angle right there, can somebody tell me what these two are to each other? Well, not by my graph, but by, hold on, I'll show you a trick I learned in the war. I'm going to take my handy dandy y is equal to, and I'm going to put in y is equal to x, And I'm going to change that to a dotted line. And hit graph. There we go. Somebody tell me what the log of x is to the 2x, or 2 to the x. Somebody tell me what they are to each other.
Parallel?
Not parallel, but you're going in the right direction. What are they? Anybody?
Symmetrical.
What'd you say?
Symmetrical?
Not symmetrical, but you're in the right area. There's another word for that when it's going across a 45-degree angle, or they look alike but going in different directions. Starts with an I.
Inverted.
Inverse. Write that down. Inverse. These are inverses of each other. Now I'm going to show you a real simple way to find the inverse of a function algebraically. And here it is. I'm going to give you a function. F of x is equal to x plus 2. The first thing you do is get rid of that f of x because it's useless. Change it to y. Second thing you do is you switch the x and y. So first thing, 1, get rid of f of x and change it to y. That's the first thing you do. The second thing you do is you switch. Y'all remember doing this in high school? X and y. 109s, you better remember it. So x is equal to what? Y plus 2. I should have used a square. Let's go with x squared. Okay? And that's an x squared. And this is going to be y squared. There we go. And now solve for y. Sorry, you can't see everything because the calculator's in the way. I appreciate y'all telling me that. Thank you. So x minus 2 is equal to y squared. Take the square root. Y inverse is equal to the square root of x minus 2. Now I just showed you how to get rid of, or how to find, algebraically, how to find the inverse. Now I'm not spending a lot of time on each of these because one, it's a review, and two, I know my 109 students saw it last semester. Okay, so with an exponent, an exponential function, and a logarithmic function, they are inverses of each other. All right? This is what the graph looks like. The graph is usually symmetrical around a 45-degree line. How to find it algebraically? Usually is set up like this. Usually. I mean, I'm not going to try to give you a logarithmic. I'm not going to try to do that because that's unbearably difficult. So usually it's with a nonlinear function besides logarithm or an exponent. Usually these are graphic. Usually they're on a graph. If I was to test you on a, it would be like a graph with a logarithm and an exponential. And then I would ask you to do one of these algebraically. And that's it. Okay? Y'all remember doing that? Somebody say yes or no.
Yes.
Okay.
Yes.
Yeah, my 109 student should be saying that because I did teach y'all that. Algebra 1, Algebra 2, pre-cal, you should remember this. Okay? All right. So let's look at, now that I've brought you up to snuff on what you need to remember, you should remember definition of a logarithm, rewriting, change base. You should remember exponential laws. and you should remember what an inverse is as far as graphic representation and algebraic. Also remember one other thing about an inverse. F of x is equal to xy. What is f prime of x, or f inverse? Yx. So your x is going to be the same as the y over here, okay? Or it's turned around. The coordinates are flipped. Always remember that too, and you'll see that on the graph when you graph one. You'll see that. Okay, hopefully all of that is a lot of review for you. Let's look at what they're presenting and see if I got, hopefully that's the wrong one. See if I got everything pretty much, exponential and logarithmic. There's the exponential function. We just talked about that. I did 2 to the x. There's how a function, and let's see, there we go. They always cross at 1. Okay, they always cross at 1 because the log of 0 is 1. So when you plug in 0 for x, you're always going to get 1, no matter what you got. Okay, you might have a vertical or a horizontal shift, but that's in a different type. On a basic exponential and logarithmic function, you're going to cross 1 on the y-axis. Okay. I want to okay, make sure you have decay. Write down decay, because decay is one of the problems you're going to be dealing with. And you need to write down, well, let's just write down this problem. This is a good problem for an example. The city of Kuprit had a population of 15,000 people in 2012. When the closing of a mine initiated a decrease in population that persists to the present, when the closing to present, whatever. Assume that the population decreased by the same percentage each year, and that in 2017 the population was 11,250. Okay, so in 2012 you had 15,000. In 2017 you have 11,250. Find P of T, the population of Capri, T years after 2012. So at 0, you have 15,000, and at 2017, you've got 11,250. Now, you could actually draw a graph. It's nonlinear, of course, but you could draw a graph basically saying, I'm just showing you this so you'll have some kind of idea. Let me make this small, bring this down. At 2012, which is 0, you have 15,000. Let's go 5,000, 10,000, 15,000, 20,000. And then at 2017, let's see, 1, 2, 3, 4, 5, 6. 5 would be 2017. You have 11,250. Well, we said this was 5 and this is 10, so 11,000, something like that. So you see there's actually a decline. You put your little car right here, and we read left to right. That little car is going what? Downhill, Hubert. That's right. So we've got some kind of non-linear. You can't just draw a linear line because we're not in that section. So you know there's some kind of non-linear curve right there. Okay, and it says the population of Kuprit T after years, and then estimate 2022. So A is going to be the setup. B, what is X in 2022? 10. So X is equal to 10 with B. and graph P of t between 0 and 10. So that's between 2012, C, graph 2012 through 2022, and find the annual percentage change. Okay, that's just draw a straight line between the two, and we'll do that. D, find rate of change, annual percent change. Okay, so I just wrote down what they did. That's all I did. I just wrote down setup. You're going to set up the problem. X is equal to 10 because they want to know 2000. So that's 5, 6, 7, 8, 9, 10. That's going to be 2022. And I guarantee you it's going to be, you know, somewhere right in there. You see that it's going to continue. So it looks like to me I got about, and this is just slack ass drawing, you know, I don't even have a straight edge on this thing, okay? And I'm getting probably around 8,000, 7,000 to 8,000. I'm going to go with 8,000 because it's a little bit higher. And that's with me just halfway drawing a graph, all right? So what's the first thing we do? Well, the first thing we do is apply this right here. P of t is equal to P of O, population at the beginning, and A of t. This is your exponential for population. Now, they would give you this in a question, or it's in the book, either one. So you need to write it down. So setup is going to be P of t is equal to 15,000. Okay, I think P of O, 15,000 to A to the t, which is going to be A to the 0. So you're going to crunch that in, and you get 11,250. 11,250 is equal to 15 A to the 5. You're just plugging and chugging. So 11,250 is equal to 15,000 A to the 5, and you're going to solve that. And they're showing that you solve it right here. I'm going to draw it on the next page. So 11,250 is equal to 15,000 A to the 5th power. And I'm going to divide by 15,000. It's really just an algebra problem. And that's going to give me 11,250 divided by 15,000 is equal to A to the 5th. How do you undo raising something to the 5th power? That's called a Q. I'm asking y'all to interact with me. Nobody's going to say a word. Can y'all hear me? Is it frozen or something?
No, I hear you. I'm just not sure.
Okay. Well, thank you. Thank you for interacting with me. All right. There's two ways to undo a power. You take that root of the power. So I can do two things. I can take the 5th root of 11,250 over 15,000 equals the 5th root of A to the 5th. And I take my red marker and I take that out. So A is equal to the 5th root of 11,250 over 15,000. So that's one way to do it. Another way is use a rational exponent. 11,250 over 15,000 is equal to a to the fifth. And that gives us 11,250 over 15,000 raised to the 1/5 power is equal to a. Now, those of you that don't know exponential notation, we're going to go visit that right now. Go back to your index card for exponential laws. And I'm going to put this one over in the corner. And I'm going to write it in blue because it's not technically a property. It's something that we learn later on. And that is the square root of a to the first power is equal a to the 1/2. Okay, you need to write that down because I'll give you another example. The third root of a to the second power is equal to a to the 2/3. What is that? Well, that's the exponent. Exponent over index. Exponent over index. I'm sorry, I'm running out of paper. Exponent over index. Always remember, you can write a radical as a rational exponent, or you can write a rational exponent as a radical. Now, you're going to be doing this a good bit because calculus does not really like radicals. Okay? They really don't like it. Really, anytime you see a radical in calculus, you need to change it to a rational exponent. So you need to remember that. And that gives you, and somebody can, and I'm just going back to the slide because they're going to do it. They're going to do the calculation. There it is. 0.944. I think that's what they come out with. Do it on your calculator. And how do you do that on your calculator? Well, let me show you. And I'm trying to take this from the perspective that we have some people in here that haven't had algebra in a while, okay? So I'm trying to, I know some of y'all invented algebra, but there's some of y'all that didn't invent it. 11,250 divided by 15,000. And I'm going to raise that, parentheses, 1 divided by 5. Well, let's say I don't like to do that 1 divided by 5. Well, that's 0.2. Do it in your calculator, come out with 0.2. 11,250 divided by 15,000. Raise that to the 0.2. Get the same answer. So 0.944 is your answer here. So I'm going to go 0.944 is equal to A. Well, the original formula for the original formula for what we just did, hold on a second. I'm trying to find it, or it's on the previous page, is P of T, the population after time, is equal to your initial population times A to the T power. Well, we know what A is now. So P of T is equal to P of O times 0.944 to the T power. And that is your formula that you're going to use. And of course, B, you're going to plug in T. So this is your setup. This is A. I'm sorry. Y'all got to talk to me when I don't show you what I'm doing. You got to say something. Oh, gosh. Y'all want to start a revolution and y'all can't even start a sentence or a conversation. All right, B. I know y'all been conditioned, haven't you? You've been conditioned not to talk in class, haven't you? Yeah, Hubert. Somewhat, Hubert. I still like to talk, Hubert. Well, I know. But some of y'all weaned on a pickle. Do y'all do this to all your classes or y'all just hate me? Which one is it?
I think math's a little bit harder to talk about, so we kind of just watch you.
Oh, okay. Oh, I see. Thank you, Miss Hollister, for giving the opinion for the whole class, because the whole class will not talk to me. Thank you. I appreciate it. Is that the way everybody feels, what Miss Hollister said? You know, just don't want to talk about math, so you just... Mr. Abdallah, you have some input? Or is that you just saying that's the way you feel? Okay. Y'all know how tough it is to teach a class that's weaned on a pickle? All right. P of 10 is equal to 15,000, and that's what you're going to plug in. And I didn't do that, but you'll see right here. Where is my PowerPoint? Where did my PowerPoint go? There it is. And that's 15,000 goes right here. I'm sorry. So 15,000. And then 0.944 to the 10th power. And that is how you do the P of 10, which is B, which I told you a while ago was 2022. So P of 10, 10 years, is equal to, crank that out, and I'm just saving time here. Let's see, where is it? 8430. Okay, so at 10, you have a population of 8430. Now, I want to ask y'all a question. What did I predict with my half-ass graph? What did I predict? Somebody tell me what I predicted with this half drawing right here.
7 or 8,000.
7 or 8,000, and with a halfway drawing, I got within 430 of the answer. I said 7 to 8,000. Okay, so you know it's not rocket science we're dealing with here. We're not dealing. You just have to take all the applications that you've learned in the last 3 or 4 years with algebra, and you just need to apply them. And when in doubt, always draw a graph. Always draw a graph. The question said it is decreasing because the mines are closing or whatever, and people are leaving, kind of like New York and California. What's happening to New York and California? People are leaving. Why? Why are people leaving New York and California? Anybody know?
High taxes?
Exactly. Thank you, Mr. Wiggins.
You're welcome.
At least I know somebody watches some news. I'm not going to say the news because
it's that 70% tax plan.
Yeah, there you go. Thank you, Mr. Berry. And now they're saying that they're going to tax or they're already rationing the water out there in California. So we're all going to die. That's what they said. That's what Al Gore said back in the 80s, that by the year 2000, the world was going to cease to exist. What happens when you have a politician trying to predict the future with science?
Don't they think California's going to be like in the ocean soon?
No comment.
Charleston.
I'm not going to comment because there are some good people out in California. I know some good Marines out there. Sir, say again, Mr. Wiggins.
I said Charleston is gonna go underwater before California does.
Well, I got a question.
Yeah.
If the oceans are going to rise because of climate change,
Yeah.
why did former President Obama buy a $3 million mansion on an island?
I don't know. I mean, you can't trust any of the politicians. But no, I think it's not because of erosion. It's not because of like raising waters. It's because of erosion most of the time. That's why.
Yeah.
So.
You know, I think it has a lot to do with how many buildings we're putting up in America and how much runoff we have going into the oceans. I think that has a lot to do with it too.
I think so.
But China don't care. They just do whatever they want to, and nobody says a word. All right. So, and say again. I thought you said something. So in 2022, the population is going to be 8 point whatever million or whatever it comes out to be. I'm not going to worry about that. C, they want you to graph it. And of course, you see the graph right there. There it is. And you could graph that with this right here. You could graph that with this equation, and I'm going to do that. So I'm going to graph our equation. Y is equal. I got to turn it on first. Y is equal to, let's see, we're going to do, I'm trying to think, 0.944 to the x. No. Oh, 15,000. There it is. 15 times 9 point, let's do that. Let's see, hold on. 15,000. Excuse me for a second. I'm having a brain bubble and I can't get out of the dadgum. There we go. 15,000. No, that's not right. Should be a negative in there. Okay, I'm not going to worry about it. But anyway, there's the graph right there. And you would graph this function right here, but you would leave t, you would leave x. The 10 right there would be to the x power. And it basically is going like this. And they want to know, so at the rate right here, r is equal to, from this point to this point, population is decreasing at a rate of 5.6 or 0.056. Write that down, 0.056. And what they're doing is they're just taking it away. They're just using the opposite of 0.944, the inverse. So you could call it the complement. What is the complement of 0.944 to 1? 0.056. So for C, you graph it. For D, you say 1 minus 0.944, and that would give you 0.056. Now that's a good homework problem, but I can tell you right now, the only thing I'm going to test you on with logarithms and exponentials are the graphs and the algebra. Now I might ask you something, okay, that has to do with decay or half-life or something like that. But I'm not going to give you, if I give you 10 questions on R6, 2 of them may be word problems. The rest of them are going to be based on the 2 index cards I told you should be writing down. Okay? Which I'm trying to get to with these slides. I didn't know I was going to have a freaking word problem at the beginning of the slides. All right? So let's move on. I'd like to get some of the rewriting. There's the base. There's the definition of a logarithm. I showed you that. Y is equal, and they got it written bass backwards. I hate when they do that. All right, but anyway, it's the same thing. A to the x is equal to y. So you might want to change yours to fix theirs. So let me go back to the definition of a logarithm. and do some changes because they do theirs backwards. Let's see. A to the x. So a to the x, so change that to an x, is equal to y. And the reason they change, some people use a y right here, and you see they use an x. And that's kind of backwards from the way people usually do it. Nobody writes x is equal to log base a of y. Nobody. But they're doing it. So x is equal to log base a of y. There we go. I just changed mine, so you need to change yours. X is equal to log base a of y. Nobody writes a logarithmic sentence like this. Nobody. Nobody puts y with the logarithm. So as I showed you before, let me go to the Google. I'm going to prove this. Where's the definition of a logarithm? Let me write down definition of a logarithm. Definition of a log. Usually they write it y. Well, I guess I just don't want to put it. There we go. Y is equal to log base a of x. This is the way it's written, the way I had it written. Thank you very much. Okay. So you just write down however you want to. I don't write it like they write it. I write it like this. Y is equal, I'm going to write it up top. Y is equal to log base a of x, and that's equal to x is equal a to the y. That's the way I write it. And you write it however you want to. Just make sure you got the right stuff in the right place. This is the way I write it. Because when do you see x equal to something versus y is equal to something in algebra? This is what you see in algebra. Y is equal to log base a of x. You don't see x is equal to log base a of y. You don't see this. So that's why I disagree with this, the way they've got it written. This is the way you see it, unless you're talking about the inverse, in which they wouldn't be talking about that on definition of logarithm. Okay, so anyway, again, I've covered mostly all this material. We're just going over it legitimately. There is examples of the definition of a logarithm. Write these examples down so you can understand how the definition of a logarithm works. Here, they are taking an exponent and they're turning it into a logarithm. So go ahead and write those down. And I will write one down on the paper and show you how they're doing it. I'll do A. Or I'll do D. Since D looks complicated and will make some of y'all quit, I'll do D. 3 to the negative 2 is equal to 1 over 9. Okay, I'm going to give y'all a few more seconds to write those down. And then we'll do one of them as an example, because these are the things I would ask you on a test. So make sure you know how to do these problems right here. Definition of a logarithm. Okay, they even wrote definition. That's usually they don't put definition of a logarithm. So I'm glad they put that because that's what it's actually called. Okay, so here we go. I'll put it back on there in just a second if you don't have them all. All right, now my definition, I use y is equal to log base a of x gives us a to the y is equal to x. Now that's the way I do it. Now, which one do we have? Well, we don't have a logarithm, Hubert. That's right. So you have an exponent. So I have this side. So I'm going to rewrite this under the problem. A to the y is equal to x. Therefore, a is equal to 3 y is equal to -2, and x is equal to 1/9. Now what? Plug in what?
Chug.
Plug and chug. Well, we've got a to the y is equal to x, so that means we're going to rewrite it as y is equal to log base a of x. What is y? -2, Hubert. What is a? And x is 1/9. Change base formula, which I don't know if they're going to go this far because you don't know the change base formula before this slide. So we're going to go ahead and do the change base formula. This is equal to log of 3 over the log of 1/9. And that should equal -2. Somebody take your calculator and do parentheses log of 3 divided by log of 1/9. This is change base formula. Change base formula. The only reason I'm including it is because most of you should have seen all of this before. So somebody tell me what you get when you take the log of 3 and divide it by the log of 1/9. What do you get? Should be
-1/2.
2. What?
-1/2.
Should be -2.
I probably typed it in wrong then.
Go ahead and check it again. You should get -2. I don't know if they went that far. Let's see what they did. They just wrote it like this. Log base 3 of 1/9 is equal to -2. So if you use the change base formula, that would be log of 3 over the log of 1/9. Okay, so that's how you use the definition of a logarithm to change an exponential equation into a logarithmic equation. Now we're going to do the opposite. Now we're going to change let me get through all, let's see. We're going to change a logarithmic to a, hold on. They're still on, oh, let's see, are they? Okay, here's one. Log base x. Okay, wait a minute. That's some more right there. I want to change the log. Okay, I guess they're, okay, I don't see where they should have the logs on this side and changing them to an exponent. But anyway, let's take log base 5 of 125 is equal to 3. Let's write that one down. Log base 5 of 125, log base 5 of 125 is equal to 3. Now, we're going to use the definition of a logarithm. The definition of a logarithm says y is equal to log base a of x yields x is equal to a to the y. So which one do we have? We've got log. We got this side. So y is equal to log base a of x. So a is equal to 5, x is equal to 125, and y is equal to 3. Plug and chug. You know, there's people that go through 12 years of school and they've never heard of plug and chug? Never. I grew up hearing plug and chug. I went to college. I went to Clemson, and my professors used plug and chug. I cannot believe that people go through 12 years of school, especially 4 years of high school, algebra, pre-algebra, and never heard plug and chug before. Nobody gonna say anything. Again, nobody wants to interact with me. So I've got y is equal to a log. I'm gonna change it into a what? An exponent. So what is my x? 125. A is 5 to the third power. And that's my answer. So you can go from a logarithm to an exponent, log to exponent, or you can go from an exponent to a what?
Logarithm.
Thank you. It's so nice to have interaction. Now, of course, this should be review. It should be, you should be saying to yourself, oh yeah, I remember doing that in Hubert's 109 class. He was such a good teacher. Y'all should be saying that, especially those of you that had me for 109. Okay, next. I think I saw there they are. Properties of logarithms. I'm going to make that big, so anybody that didn't write it down a few minutes ago, there it is. That is the product rule. I'm sorry, the product rule, the quotient rule, and the power rule. And there's also one of those little basic rules, property number 4. That's one of those basics that you should know. Anytime the base is equal to the number, then it's equal to 1. And the log of 0 is equal to 1. And you can't take the log of a negative number also. See here? M and N have to be positive. You can't take the log of a negative number.
Hubert, which ones were the ones you said that we couldn't do in the calculator?
The change base formula.
Okay.
We'll get to a slide toward the end here in a second. You'll see. Change base is the one you can't, you have to change the base. You can't take the log of base 3. Now, what if I give you this on a test? What if I give you log base 3 of 3? Well, since the base is equal to the 3, since these two are equal, you use this property that says is equal to 1. Or you could do the change base formula. Change base formula says log base 10 of the big 3 over log base 10 of the little 3. And what is that? What is something over itself?
1.
So either way you do it, you can either do it by the rule, log base A of A is equal to 1, or you can use the change base formula. Since this is not a 10 or an E, you can use the change base formula and put it like that, and you see that it comes out to be 1. Either way, you're going to get 1 as an answer. But you'll see the change base formula here in just a second. Here's some more. There it is right there. Anytime you have the log base any number of a number, you can take log base E or log base 10 of that number divided by log base E or log base 10 of the base. And you'll see that hopefully with an example here in just a second. Log of 1 is always 0. I told you that a while ago. Okay, this one you might want, I wrote it down also. I told you to write it down. Anytime the two numbers add up, are equal to each other, if that number is raised to a k power, then k is the answer. And anytime you have the base of an exponent equal the base of a log, the answer is whatever's after that base. That x right there. That's the answer. Again, most of you should look at these rules and go, I remember that. I remember going over this. Okay, here is an example right here of 2 logs. I'm looking at them to see. Okay, it looks like to me you could rewrite these by the definition of a logarithm. You could use the change base formula since you don't know what A is here. And you could do A is, or log base A, that'd be the log of 2 over the log of A. That wouldn't work. Yeah, you could. You could have an algebraic equation right here. Log base A of 6. Okay, well, how do you get 6 from 2 and 3? That means I want y'all to interact with me.
You multiply them.
Multiply. So I'm going to do log base A of 2 times 3, which is equal to log of A plus the log of B, which is equal to 0.301 plus 0.477, which is equal to 0.778. Lord, it's a miracle. Write that down. I don't do a lot of these on the test, but I tell you where you will see this. You'll see that on a standardized test. That's exactly the kind of questions they put on, as far as logarithms, that's what they put on a test, on a standardized test. Because it's kind of tricky. You're trying to think of, oh, well, how do I put that in a calculator? When actually it's a property. And you should feel good about yourself. That way you don't have to put too much makeup on and have an orange face and a white neck, and people call you an Oompa Loompa. Or people make fun of you because of the things you do to your vehicle. And nobody says a word. But I'd at least get some kind of reaction. Nothing. You know, it's hard to teach to a class that don't talk. Mr. Abdallah, how was your weekend? I haven't heard from you today. You being awful quiet. You ain't sick, are you?
No, I'm doing fine.
You just don't want to talk to me? You just want to follow the crowd and leave me hanging, huh?
Yeah, kinda, yeah.
Yeah, I know you're like that. Thank you. Appreciate it.
Yep.
It's all right. You're going to make an F in this class. All right. So next, log base A of 2/3. How can I do that? Well, that would be log of A of 2 minus log A of 3. And now you subtract the 2. So that would be log A of 2 minus log A of 3, which would be those decimals subtracted from each other. And whatever that comes out to be. So there's another standardized test question you might see on a test. And again, why would they put that on a standardized test? Because you would think you were going to type that in a calculator, or you'd use the definition of a logarithm. But when I saw the 6 pop up, I knew that's what they were doing, because there's only one way to get 6 from 2 and 3, and that's with multiplication. And that's the quotient rule. I'll let y'all have a second or two. I know we got to finish up here in 3 minutes, but I've already called the roll. And if somebody came in late, I called the roll at the beginning of class, so you might want to hang around and let me know by showing me your hands. Did anybody come in late? Show me your hands. I got you, Mr. Abdallah.
Here, I came in late.
Okay, hold on. Just leave your hands up. Let me go back to the handy dandy. Well, I'll turn that on and just leave your hands up if you came in late. And when everybody leaves, I'll get you taken care of. Thank you, Mr. Ridings. Yeah, I figured y'all would come in late. We talked about y'all while y'all wasn't here.
Talk
Y'all want
about-
to know? Yeah, we talked about y'all.
Sorry, I'm driving to class right now.
That's all right. Don't have a wreck. You just listen, okay?
Yeah, I'm just listening.
Okay. And watch the video later.
I will.
Oh, so you're the one. Huh. All right, what does this one say? Log base 8 of 81. Well, what pops into your mind when you see log base 8 of 81? What pops in your mind when you see 81?
9.
9 to the what?
Second power.
Exactly. Now, log base A of 81 is equal to log base A of 9 to the second power, which is equal to 2 log base A of 9. And you could carry that further, and you could say log base A of 3 times 3, which would be 2 log base A of 3 times 3. Well, wait a minute. You could do 3 to the 4th power. Yeah, I'm sorry. You could do 9 to the 2nd power or 3 to the 4th power, and that would be 3 log base A of 3. And then you could do this, and that would be log 2 times log of 3 plus log of 3, or 3 times the decimal, and that's going to give you your answer there, and then 2 times the decimal plus the decimal, and that's going to give you the same thing as that number right there. So you could do this 2 ways. You could do it with 9 to the 2nd power, or you could do it with 3 to the 4th power. It doesn't matter. You'll get the same answer. So I'm going to jump over there and finish up this problem. Oops, sorry. Okay, there you go. There you go. Okay, it's 0.477. So that's going to be 0.477 with a 3. Yeah, or 4. I'm sorry, with a 4. I'm sorry. And that would be 0.477 and 7, and here 0.477, 0.477. You should get the same answer. 1.908. Okay. All right. Somebody write down that we're on R6, number 20. Miss Hollister and Holcomb, if y'all would do that, R6, slide number 20. We got a few more to go over. Now, what should you be working on right now? Everybody should be, and I'm writing this down for people that don't know, you should be at R2, R4, R5. Y'all should have those done or questions sent in. Right now, you should be working on R6, probably 1/2 to 1/3 of the homework you should be working on. Okay? All right. Those of you that need to go, but let me get the people that don't leave yet, people that have your hands up. Don't leave yet if you don't mind. The rest of y'all can skedaddle. I've already got y'all here. All right.